Okay, Assalamualaikum. Now we are going to proceed to chapter 19, the first law of thermodynamics. Right. So the first subtopic here is about heat and internal energy. Now let us define what is internal energy. Right. Now internal energy is represented by a symbol capital U. Right. Now basically a system. Okay, when we have a system, okay, and we expose the system with higher temperature. Alright, ataupun we increase the temperature of a system. Right, so katalah ni system, we increase the temperature of the system. So what happened? We can say that the system gain energy, isn't it? Alright, the system gain energy. But who exactly gain the energy? Right, so the one that gain the energy here is the atoms and molecules. Okay, atoms and molecules in the system. Alright, so the energies, okay, of the atoms and molecules include the kinetic energy and potential energy, and also energy that comes from the vibrations of the atoms itself. Right, and the kinetic energy here, we have several types of kinetic energy. We have translational kinetic energy, and we also have rotational kinetic energy. Alright, now the sum of these energies, okay, the kinetic energy, potential energy, and vibrational motion of the particles, okay, will give us the definition of internal energy. Alright, so we can say that as the temperature increase, the internal energy of the system also increase. Alright, so the internal energy of the system depends so much on the temperature. Right, now the unit for internal energy is Joule. Alright, Joule sama dengan tenaga, dia adalah tenaga. Alright, so the unit for internal energy is Joule. Alright, so what is heat? Okay, heat is basically the transfer of energy, okay, from a system to surrounding because of temperature difference. Right, so whenever we have the temperature difference, heat will be transferred. Right, the symbol for heat is Q. Alright, symbol for heat is Q, and the unit is also Joule. Alright, so ini adalah heat. Okay, next we can also relate heat dengan work. Alright, now work is basically the force used, okay, to transfer the energy, okay, between the system and the surrounding. Alright, or in other words, you can also say that it is a measurement of amount of energy transferred to system from its surroundings. Alright, so meaning that, okay, when we talk about work, we cannot say work of a system. Okay, that's wrong. Okay, because the system ni dia tak belong work. Okay, meaning that the work is not belonging to any system. Right, it is not kata-kata apa, not a belonging, okay, to any system. Right, so work is either done on the system ataupun the work is done by the system. Alright, so when the work is done on the system, basically the system will increase its internal energy. Work is done on the system. Alright, so kalau work done by the system, it means that okay, the system release energy, okay, ataupun expel energy to surrounding. Alright, so we are going to look more on this in the next subtopic. Alright. Now, what is calorie? Alright, so calorie is other unit untuk energy. Alright, so calorie ada dua. We have small c and capital C. Alright, calorie is basically the energy transfer necessary to raise the temperature of 1 gram water, okay, from 14.5 to 15.5 ataupun by 1 degree Celsius. Alright, so this is the calorie. Now, kalau nak relate calorie dengan joule, okay, we use this conversion. 1 calorie equals to 4.186 joule. Right. Now, for big C, okay, big C, 1 big C equals to 1000 calories. Right, and it is equals to 4186 joule. Alright, now let's go through one example here. Okay, to identify the relationship between work and energy. A student is a dinner rated at 2000 calories. Alright, so given is 2000 calories. Alright, now we know that one big calorie, okay, 1 capital C here is equals to 1000 calories, small c, isn't it? Alright, so kalau 2000, So you akan ada 2000 times 10 to the power of 3 calories. Okay, small c. Alright. He wishes to do an equivalent amount of work in the gymnasium. Equivalent amount of work meaning work ni nak sama dengan 2 atau I make it as 2 times 10 to the power of 6 joule. So calories, alright. So calories, okay, wants to do work, okay, in the same amount, okay, by lifting a 50 kilogram barbell. How many times must he raise the barbell to expend this much energy? Now, meaning that the energy associated here is the potential energy, isn't it? Alright. Okay, because the student, okay, only want to what we call it? Only want to uh, increase ataupun only want to raise the barbell. Alright. So the energy associated here is the potential energy because it is associated with the height of the barbell. Alright. Okay, so the work here would be equals to potential energy mgh. Since we want how many times he raised the barbell, alright, so kat sini kita tambah dengan n, berapa banyak. Okay, berapa banyak. Assume he raises the barbell 2 meter each time he lifts it and he transfers no energy when he lowers the barbell. Alright, so we have that. Okay, in joule. Okay, kalau kita if you want to use mgh, alright. So make sure mass in kilogram. Okay, g is in meter per second squared. Okay, and then h is in meter. So automatically all this will give you unit joule, isn't it? Alright. So therefore you have to convert calories here into joule. Alright. So yang ni adalah 2 times 10 to the power of 6 times 4.186 joule. Alright, so all this equals to mgh. Alright, so the barbell is 50 kilogram. Okay, and then 9.8, and then you have h here. Okay, he every time he raise the barbell, okay, h equals to 2 meter. Okay, and then kali dengan berapa banyak dia, how many times he raised the barbell. Alright, so here and you will get, okay, approximately 8.54 times 10 to the power of 3 times. Okay, get it?